Hello everyone, let's design a 32-bit up and down counter and implement it on the Terasic DE1-SoC board, where 4 MSB of a counter will be assigned to 4 LEDs of the DE1-SoC board. So let's start. Now we need to create a new project. Go to File, New Project. Next, I'm changing the directory of this project and I'm gonna rename this project as well. Once you assign the directory of the project, then you have to give a name for the project, then click next, next, next. So this is the very important part, since we need to assign a board. This is a very important part, as this FPGA has to match the FPGA in the TI SoC board. So the family would be Cyclone 5 and the device would be 5CSCMF5F3176. Then click next, then next, then finish. Now create a new Verilog file, new Verilog HDL file. So once you have written the Verilog code, you have to compile it. Once the compilation is done, you will get all the tasks in a green tick. Now the next step is to generate a STC file. In order to do that, go to Files, New, System Design Constraints file, then press OK. So once you have created a STC file, again you have to compile all the files. Once it's done, then the next step is to compile the IO assignment analysis. So after this compilation, then we will have to assign the pins. For assigning the pins, we need to click assignments, then the pin planner. So in this we have to, so in this location part, we have to assign the pins with their respective location based on the data sheet. So I have filled out the location by assigning the pins looking upon the data sheet. Once done, let's close this window. Now let's program the FPGA board. If you come down in the compilation, we will find the program device. Click on this. Then the window is going to pop up. So in this part, you have to right click, go to edit, change files, output files. Then you have to select the .soc file, open. Once it's done, click on the program configure, then click on the start. Once you click start, you're gonna find program as 100%, like it has been programmed successfully. So here you can see that the board is designed and functioning properly. It is counting upwards. This is the reset pin. If I reset, it starts from 1. And this pin is the direction pin. Now it's counting from upwards. If I push down, it starts to count downwards. As now we have seen how the board works, let's understand it more thoroughly by looking at the waveform. So as we can see, when the direction is high, let me pull this. So whenever the direction is high, the counter starts upwards. So it goes from 0 to 1, 2, 3. You can see the numbers are counting upwards whenever the direction is high. 4, 5. 6. So whenever the direction is assigned 0, it starts to count backwards. You can see the count is changing from 13 to 12, 11, 10, 8, 9, 8, 7, 6. From this we can conclude that our design is working perfectly, since it is counting upwards whenever the direction is high and downwards whenever the direction is low. One last look at the board. So this is a 4 MSB of a 32-bit counter. Thank you.